Mohammed, yes, I can do cos 15. Did I not do that one at some point? Let's just go back because it seems very familiar. It feels like maybe we've done cos 15. My intention was, oh, we did cos 75. Okay, that's why it feels familiar. Okay, any other questions? Don't worry, Anga, your mark is out of the total, which was probably out of 15 or 20, depending. I can't remember what the quiz was out of, but so that's the percentage. Okay. Right, so cos 15 was one of the questions that I was going to do that we didn't get to in the end. But let's see if we can do that one at the end. We just need to make some headway through our lesson this evening. And then towards the end, Mohammed, I think in the last 10 minutes, I'll make time for doing cos 15. Rightio, what have we forgotten, Miss Go? Oh, house rules. Okay, so since we've got some newbies in the house, let's do house rules. So our house rules are pretty straightforward. We ask that you keep yourself on mute, just so that we don't have unnecessary background noise that might disturb people who are trying to think and concentrate. So please keep yourself on mute. If you have a question, please raise your hand like you would in a normal classroom. You raise your hand by putting your hand emoji up in your Zoom controls, and I will see it, or Ms. Coco will see it, and we'll give you a chance to ask your question. Remember to unmute yourself to ask your question, and then to put yourself back on mute after you've asked your question. Okay, the chat, please reserve the chat for questions and answers about the lessons. Please do not exchange personal information in the chat or DM each other and really distract yourself and take away from the time that you've committed to be here learning maths. We are all here together, and of course it is nice to meet new people, but that's not really what this is about at the moment. This is really about maths and learning maths and doing so together where everyone feels safe. Okay, so having said that, we are kind towards each other, we support each other, and we just always remember that we are here together as we make our way through matric and journey towards that final paper and those final results. So let's keep it a positive and happy experience for everyone, which it has been so far. So well done to everybody. It's really, really nice to see you all here. It is so cold in Cape Town this evening. Ms. Coco, how are you there in KZN?
I have my heater on right next to me. I've got a blanket on, and I'm drinking tea, and I've got a jersey and another jersey inside the jersey. So you can imagine how cold it is in KZN right now.
Nothing seems to really work. Anyway, I'm sure as soon as we start thinking, we're going to warm up.
Yeah, absolutely.
Right. So Ms. Coco is our teaching assistant. She's here to keep me on my toes and remind me and bring things to my attention that I might overlook, and to help me not make mistakes. And she's also here to help you if you have any technical issues, and she can also answer questions. She's very smart. She should be teaching this lesson, please. She can do parametric equations. I can't.
I try.
Okay, right. So we are gonna this evening. So what we've been doing is we have been working with these compound angle and double angle identities. Remember, they are on your formula sheet. So it's just important to recognize the correct one and to write it down correctly. Sometimes we've seen it needs a bit of changing around and maneuvering so that it fits into the pattern, but for the most part, it's just recognizing the compound angle or the double angle and putting it into its identity. that is what we did in our first lesson. Our second lesson, we did compound and double angles on the Cartesian plane. So that's when we have to draw two sketches because we are given two angles, and then the questions generally relate to compound and double angles. This evening, we are going to combine. Remember what I said at the start, if you were here at the start of this short course on this, that we are basically doing everything we've done so far in trigonometry. So working on the Cartesian plane, reductions, equations, we're just adding this layer on top of it now with the compound and double angles. So that's what we're going to get to this evening. We've done Cartesian plane with the compound and double angles, and now we're going to do reductions with the compound and double angles. So for reductions, you need to think immediately of all stations to Cape Town, or CAST diagram, the one that I drew here in pink. So that is what reductions are about. So reductions, 180-degree rule, 360-degree rule, and 90-degree rule, negative angles, all of those things have to do with reductions. And if you were here at the beginning of the second term, we did a long course in trigonometry and we revised all the grade 11 trigonometry. So it's if you're a bit shaky still on that, you can go back, please. All our recordings are on our website and you can watch those lessons and do those quizzes that are available. The quizzes do not expire, so you can still practice reduction. So just look for the lesson called reductions, or it'll be called reductions or grade 11 reductions, and you can practice that if that is something that you need to still work on. Okay, so what I've seen happen sometimes is that, and the brain is a funny thing, because we get so geared at looking at compound angles that we forget about reductions, and then we start applying the compound angle identity to reductions. So that is just something to watch out for. Okay, so reductions are still what they are. You don't have to apply compound angle identity to something like this, sine 360 minus alpha. Okay, that is a straightforward reduction that we now are going to practice, just as a quick refresh, as we sort of see how it works as we get towards compound angles. Okay, so I'm going to do the first one just to remind us. So sine 360 degrees. So your thinking process when you do reductions is 360 minus alpha. Which quadrant is that? That's the fourth quadrant. The fourth quadrant, sine is negative. So we're going to reduce sine 360 minus alpha to minus sine alpha. And put what you change into a bracket so that we don't get confused with the signs. Cos 180 minus beta, 180 minus, that is the second quadrant. Cos in the second quadrant is negative, so we reduce it to negative cos beta. Then cos 360 minus alpha. Cos 360 minus alpha is the fourth quadrant. Cos is positive in the fourth quadrant, so this is going to be cos alpha. And then sine 180 plus beta, 180 plus beta, that gives you your quadrant, whatever's in the bracket, so that's the third quadrant. And sine in the third quadrant is negative, so we're going to reduce that to negative sine beta. Okay. Now we need to simplify from here, and a minus sine alpha times the minus cos beta is going to give me a positive sine alpha cos beta. And here we've got a plus cos alpha minus sine beta, so that's going to give me a minus cos alpha sine beta. Okay, and now this is starting to look like a compound angle identity, and it is the compound angle identity. You can keep them right next to you, because you're going to need them. If you've got a formula sheet there that you might have gotten from your teacher when you did your exam, we'll see that sine alpha cos beta minus cos alpha sine beta. So sine cos sine follows this pattern here. So that's going to be sine alpha minus beta. Okay, so that's where we come in now with the compound angles along with our reductions. Okay, can I just see in the chat, just put a thumbs up, thumbs down? How is that looking? Lots of thumbs up. Well done. Okay, well, good stuff. Since we've got so many thumbs up, let's crack on with question B, and I'm going to give you 3 minutes to do that one on your own. Okay, so let's just have a look at question B. So we've got a negative angle. So you need to know what to do with a negative angle. We've got 360 plus theta, and then we've got 90 minus theta and 540 plus theta. Okay, I'm going to give you a chance for 2 minutes. Let's see how you go. See if you can do this one on your own, and we'll check back in at, let's make it 3 minutes, 18 minutes past 5. One more minute. Remember, when you have an answer, pop it in the chat. Share your thoughts with us. Okay, let's see. Doesn't matter if you haven't finished it. Let's see how far you got. So let's take them one by one. Oh, nice. Here's some answers. Sine of 2 theta. And then Sibusisu, if you've got the 2 angles, simplify what's in the brackets as far as possible. Pelo says 1. Okay, let's see. So cos of minus theta is a negative angle. And that's going to land you in the 4th quadrant, because remember, with negative angles, we rotate in the clockwise direction. So if we go negative theta, that's the fourth quadrant, and cos in the fourth quadrant is positive. So we can just reduce it to cos of theta. Then cos 360 plus theta. 360 plus theta, that means we have rotated right around the Cartesian plane and we're back. Because it's 360 plus, we've made one full revolution and a little bit. So that is actually the first quadrant, 360 plus. And cos in the first quadrant is positive. So cos theta. Then cos 90 minus theta. I wonder who remembered what we do with the 90 minus theta. 90 minus theta, this is the 90-degree rule. So cos must change to sine, and it is going to remain positive because 90 minus is just the first quadrant. And then sine 540, that's it, Aluwani, that's exactly what happens. Sine changes to cos and cos changes to sine when it's 90 plus or minus theta. So sine 540 degrees, that is just going to reduce to, we can subtract 360 from the 540 because 540 is bigger than 360. So we can subtract 360 from it. That gives me 180. I'm just going to do it here. Sine 180 plus theta. And that quadrant is indeed the third quadrant. So sine is negative in the third quadrant. So we get negative sine theta. Okay. So we've got cos theta times cos theta, which is cos squared theta. And then we've got sine theta times a minus sine theta gives me a minus sine theta. Just fix that quickly. Okay, so that's a minus sine squared theta. And if you look at your different options for your double angles, cos squared minus sine squared is indeed this one here, cos of 2 theta. Okay, so I see some of you guys are writing it as theta, you're writing it like this, theta plus theta. Okay, simplify what is in the bracket. It is cos 2 theta. Okay, so don't leave it like that. You have to simplify it further. Why the first cos becomes positive? The first cos is cos of negative theta, and negative theta is with negative angles. Remember, it's we are rotating in this direction. So if it's just negative theta, it is going to be in the fourth quadrant, and cos in the fourth quadrant is always positive. Okay, well done, everybody. I think we must do one more. Let's do question C. And again, we'll take 3 minutes to do that one. Pop your answer in the chat as soon as you're ready. Mohammed's done this one already. Wait for everyone else, Mohammed. Okay, we are checking back in at 25 past to see how everyone's doing. That's okay, Ria Lebucha. We are going to have a look at it right now. Time's up, 25 past. Let's see where you got stuck. Okay. Right. Okay, so sine 180 minus theta, that is 180 minus is the second quadrant. So sine in the second quadrant is positive. So we reduce it to sine of x. Put a bracket, prevents any confusion with signs. Then sine of 90 minus x, it's the same rule we had in question B. The sign must change to cos because of the 90 minus x. And 90 minus x is the first quadrant, so sine just stays positive. So it's cos of x. Now we've got this here, x minus 180 degrees. So where on the Cartesian plane will be x minus 180 degrees. So you can think of it that way, or if you remember from our earlier classes when we did all of these reductions, what you can do is you can add 360 degrees to this, because this is something that doesn't fall into the normal sort of quadrants that we recognize. So 180 minus or 180 plus, it's x minus 180. So a good trick that you can learn for this is to add 360 degrees to it. And when you add 360 degrees to it, you're not doing anything wrong because you are just going around one more time. So 360 is a revolution. So if we add 360 to minus 180, we get x plus 180. And now that's much easier to see that we are actually in the third quadrant. Okay, and you can do the same with sine of minus x, because minus x you can also add 360 degrees to, and that will give you 360 minus x, which puts you in the fourth quadrant. So sine in the fourth quadrant is negative. Okay, let's simplify a little bit further. So sine of x, cos of x, then cos of 180 plus x, that's the third quadrant, so that's minus cos x, because cos is negative in that quadrant, and then we still have the minus sine x that we are going to multiply together. So we get sine x cos x plus cos x sine x. Okay, like terms here, sine x, cos x, sine x, doesn't matter that this one is the other way around. They are exactly the same. So that gives me 2 sine x cos x and 2 sine x cos x. That is a double angle, and it's the double angle for sine of 2x. Okay. Leabona got sine of 2x. Sibusiso got sine of 2x. Wonderful, everybody. Well done. Belinda as well. Please make sure you understand where you got stuck. And if anyone else, if you did not get sine of 2x, please make sure that you understand where you've went wrong, and yeah, that you can carry on and not make the same mistakes. Okay, right. Let's step it up a notch, and we're going to get around to some of these identities, or not really identities, just a bit more stuff that we have to simplify. So here's our first question. Let's change colors from this pink. Let's make this blue. Okay. And yeah, let's do another. This one might take a little bit longer, but let's do another 3 minutes. See how you go with this one, question 1, which is a lot more like the type of question you will get in the exams. So have a go. Okay, I'm giving a few hints for those of you who might be stuck. With the 720, subtract 360. That'll help. Everything else is as it should be and should be easy to deal with. Remember that squaring a trig identity always makes it positive. Okay, let's have a look. We can change the cos 720 minus 2x to cos 360 minus 2, sorry, it's alpha, not x. Then sine squared of 180 plus alpha, that is in the third quadrant. And sine is negative in the third quadrant, but you are squaring it, so it will just go positive. Sine squared alpha. Then we've got sine of 90 plus alpha, which is in the second quadrant, and it's 90 plus, so this must change to plus cos alpha. Okay, it stays positive because we always look for the sine of the original function when we do 90-degree rule, and sine in the 90 plus quadrant is positive. And then cos alpha plus 180, that's the same as going 180 plus alpha, and that's also third quadrant, so we can just make it negative cos alpha. Okay, we can reduce the top further to, so cos 360 minus, cos is positive in the fourth quadrant, so that is cos 2 alpha. And then we've got sine squared alpha minus cos squared alpha at the bottom. And that's going to give me sine squared minus cos squared. That looks an awful lot like it could be cos squared minus sine squared. So let's see if we can manipulate it to be that. We can take out a minus and basically do a switch around and go cos squared alpha minus sine squared alpha. And that's going to give me cos 2 alpha over minus cos 2 alpha, and that is minus 1. Okay, so you changed your mind. You went minus 1 and then you went 1. Adewani, check why you got 1. Many of you got 1. How did we get 1? Should be minus 1. It should definitely be minus 1. Yeah, cos in the fourth quadrant is positive. So cos of 360 minus 2 alpha is is positive. So your minus comes from having taken out a minus in the numerator to do the switch around. So that is how we got minus 1. Okay, went wrong with this, with the signs. Ms. Coco, you have your hand up.
I do. I do. Could I just have a look at your number C? I think Kia may have spotted something that you and I may have missed in the question before.
Question C?
Yes. Or your answer to question C before.
Okay. Oh, but is everyone good with 1? With this question we just did?
Yeah. I think because it is a double angle, just the standard double angle formula. I hope you guys are understanding.
Yes, and just the switch around at the bottom. Okay. Yes. Question C. Yes. I'm pretty sure question C is correct.
Yeah, I think Kia may have gotten a bit confused. Kia, I hope you can take a screenshot quickly and go see how ma'am's fourth step is actually a double angle sine identity, because sine x cos x plus cos x sine x, which is the same as sine x cos x. You can just switch those two around will give us
Yeah.
the double angle identity for sine.
Yeah, it's like AB and BA. It's the same thing.
So if you could just maybe take a quick screenshot for me, Gia, and then I'll continue my conversation with you in the chat. Okay.
Okay.
Thank you
Belinda,
so much, ma'am.
No problem. Belinda, you've got your hand up. Go ahead.
Hello.
Hi.
I want to ask on the sine 90 plus alpha. The answer won't be negative sine negative cos alpha.
No, it won't be negative cos alpha. When we do the 90-degree rule, we always look at the original function. So sine of 90 plus alpha. So 90 plus is in the second quadrant. Let me draw it. So here's 90 plus, and sine is positive in that quadrant. So we leave it as positive. We change the sign to cos, but it stays positive.
Okay, thank you.
Sure. The 90-degree rule, there's so many little things to remember with it. Anga, you next. Go ahead, Anga.
Hello guys. So in question number 1, there's cos 2a, okay? So I changed it to cos squared a minus sine squared a, and in the bottom it was cos 2a divided by sine squared a plus cos it's cos 2a divided by sine squared a minus cos 2 squared. Isn't that the same thing, like log cos 2a then divided by sine squared a minus cos 2a, then you change the cos 2a to cos squared a minus sine squared a? Isn't that the same thing?
So you're saying you changed the cos square to 1 minus...
No, I changed cos 2a from the top to cos squared a minus sine squared a. Alpha, I mean.
Yes. No, that's right. You can do that. It's more work. But you can do that as long as you took out the minus at the bottom, because the top and the bottom must be exactly the same for you to be able to cancel it out. But it is fine for you to have made that cos squared a minus sine squared a at the top as well.
Oh, okay. Thank you.
Okay. All good. No more questions? Awesome. Okay. So what I think we're going to do next is move on to some numerical reductions, where we are going to reduce and use special angles. Okay, so without a calculator, basically. Okay, so I'll do this first one with you. Primrose, I'll remind me at the end, I'll go back and then you can take a screenshot. So let's have a look at this one here, question A. So sine of 154 over sine 193 cos 373. Okay, so they're numerical reductions because we need to change them to numbers and where possible use our special angles to reduce them. Okay, so your thought process for this one is 154 is in which quadrant? That is the second quadrant. So what must I subtract from 180 to get 154? So that is 26. And sine in the second quadrant is positive. Okay, so it's like a three-step process. Yeah, so what quadrant is my angle? What must you subtract? and then what is the sine of your trig ratio. Okay, so for 154, that's 26. Sine of 193, so sine of 193, which quadrant? That will be in the third quadrant. What must I add? So that's the 180 plus quadrant. So what must I add to 180 to get 193? And that is 13 degrees. And in that quadrant, sine is negative. So negative sine 13. And put a bracket to prevent sign confusion. Okay, so cos 373 degrees. 373 is in the fourth quadrant. That's the 360. No, it's not in the fourth quadrant. It's in the first quadrant.
Yes, ma'am. First
quadrant. First quadrant, because we go 360 plus 13. So this will be cos of 13 degrees. Okay. So now what do we start noticing? We've got a 26 and a 13 and another 13. That is starting to look like a double angle because 13 plus 13 is going to give me 26. So the 26, the sine 26, we can expand using the double angle for sine. So that is sine 13 times cos 13. And at the bottom, we've got minus sine 13 cos 13. And that can all divide sine 13 with sine 13 and cos 13 with that. And our final answer is negative 2. Okay, right. Let's see if we can try one on our own. Maybe I can, let me see where, yeah. Let's give question B a shot. Let's take 3 minutes, see how we go, and look out for double angles and compound angles in your reductions. Okay, I'm going to start so long and carry on working, check as we go if you are getting the correct answers. So cos squared of 173. 173 is in the second quadrant. So you subtract 7 degrees from 180 to get 173. Cos is negative, but because we are squaring it, it is going to remain positive. So cos squared 7 degrees minus sine squared 7. Okay, so already you should notice here sort of alarm bells going off. We've got the double angle for cos there. Okay, so sine of negative 66. Negative 66 is in the fourth quadrant. So that is going to be negative sine 66. Because fourth quadrant is where sine is negative. Then cos 90, 190, that is third quadrant. Cos is negative in the third quadrant, and we'll add 10 degrees. Cos 66 is already reduced as far as possible. Sine of 350, 350 is in the fourth quadrant, and we subtract 10 degrees to get 350, and sine is negative. So it's negative sine 10 degrees. Aha. So you can check so long if that is what you got. And I'm going to leave it here for a moment, see if you can finish it from here. Check that yours is correct so far, and then give it a shot to finish it. Yes, Anga, go ahead, ask your question.
Miss, where did we get the 7 in the top, in the numerator? Cos squared 7 minus sine squared 7.
So 173 degrees, that is going to be, if you look at your Cartesian plane or at your cos diagram, that is going to be here in the second quadrant. That is the 180 minus x quadrant. So we subtract from 180. What do we subtract from 180 to get 173? That is 7 degrees. Okay, so that's the numbers sorted out, 7 degrees. And then cos in the second quadrant is negative, but because we're squaring it, it's going to stay positive. So it's cos squared, 7 degrees.
Okay, Miss, thank you.
Cool. Okay, I'm waiting for an answer. Has anyone got an answer yet? 1 over tan 14. We're going to see if that's right, Belinda. Let's get some more answers, guys. Mohammed's got cos 14 over sine 76. Waiting for everyone else. Liabona, Tamika, Andiswa, Sibusiso. Everyone who normally posts answers. There's Ms. Lali's answer. So if you got cos 14 over sine 76, you can still go further. You can still go further, okay? Remember the co-ratio, the 90-degree rule. Use the 90-degree rule to simplify it further. Mkhlali, you are right. It's 1. Well done. Okay, let's see how we got there. Okay, so the top you should recognize as the double angle for cos. So the double angle is the 7 plus the 7, okay? It's always twice the number that you see there. So it's cos of 14. At the bottom, we can do sine 66 cos 10. This we can definitely simplify with the signs, and a minus make a plus. So it's plus cos 66 sine of 10. So this you should recognize as the compound angle for sine. So it's 66 plus 10. So we go cos 14 and then sine 66 plus 10, because we recognize the pattern, okay? Sine, cos, cos, sine, plus. Okay, And that gives me cos 14 over sine 76. Well done, everyone. Lots of you got up to this point. And then just remember 14 and 76 add up to 90 degrees. So you can apply your 90-degree rule and your final answer is going to be 1. Because cos 14 and sine 76, if the angles add up to 90 and you have cos and sine, then they basically cancel out. They divide evenly. And if you don't believe me, you can check on your calculator. Okay, wonderful. Good try, everyone. That was really, really good because that wasn't the easiest. So this is really, really good of you. Even if you didn't get the whole thing till the end, make sure that you get at least 5 or 6 of the 7 marks. It's good. It's good that you get that far. Well done. More practice is going to get you your full marks. I promise you that. Okay. Well done. So I think I owe people a few things here. I need to go back to C for Belinda. Just take a screenshot. There you go. And then I'll do cos of 15 for Muhammad in the last few minutes. If anyone wants to stick around for that question, it was on your quiz. So I'm happy to do that one. But other than that, Ms. Coco, I think we've got a poll this evening. So Ms. Coco is quickly going to get you guys to do the poll. Over to you.
Thank you very much, guys. Those of you who have been here before, you know exactly what's going to pop up on your screen. You're just going to give me an answer. Merdy is asking to take a screenshot of the last thing we just did. And I'm a little afraid to run the poll if Merdy still wants to take a screenshot because my poll is going to show up on his screen.
Okay, Ms. Coco, I think, yeah, let's run the poll and then we can do screenshots afterwards.
Okay, awesome. All right, guys. Yeah, all you have to do is just answer whichever one you think is okay for you. How did you feel like the lesson was today? I personally love this because I love trigonometry and this is a really nice section for me.
Yeah,
so
me
I
too.
had a lot of fun. I had a lot of fun. That's the maths nerd in us, Miss Marley's.
Oh no.
This stuff. Yeah. So I hope you guys are like, if not enjoying it, at least enjoying getting it right, because that's the whole idea, to learn from our mistakes and enjoy getting maths right.
Yeah.
But yeah, all you have to do, guys, is just answer the question for me, and then if you, I think that's it from our side. Ms. Marlies,
I think you still have a few more that need to complete the quiz.
One more person, just one more. I don't know who this one person is. Please, please put us out of our misery and vote. There we go. Awesome. All right.
Awesome. Well done.
All right.
Okay.
I think Chai, I hope I'm saying your name right. Chai has a question. If we can take that question.
Ms. Coco, are you taking the screenshot?
Yes, I have taken it.
Okay, awesome. So I can close that. All right. So I've got C up for I think Sue needed C. Please just let me know. Primrose, you wanted C. Please just let me know when you're done so I can change the screen to the last question. I'll wait to hear from you, Primrose, before I change it. And then Murdy, I'll change the screen so that we can see the last one. And I'm going to take Chai's question. Go, Chai. Chai, you can ask your question.
I was saying I'm the person who didn't do the quiz because we had load shedding that the power didn't come back as expected, so I couldn't do the quiz at the time.
The quiz.
Yeah.
Chai, you can always go back and do the quiz. They are available. We don't take them down. So if you still want to go do your quiz and get your results, you're welcome to.
Okay. Thank you.
All right.
Ma'am, Andisa is asking, when are we going to teach statistics? And that is a very complicated question. At the moment.
If we teach it, it'll be in the 3rd term.
I think that's as far as our knowledge of when statistics is going to be taught goes. We unfortunately don't have many answers for you, but it is coming up. We promise it is coming up, Andisa.
Yeah, it will be there. Okay, I am switching for those who want to take a screenshot of these 2 questions. And then for question C, I did something different, but same answer. Mohammed, as long as what you did is legit, then it's fine. That's a beauty with Trig. There are different ways to do things. When are we teaching Euclidean geometry? Euclidean geometry. I think Euclidean geometry has passed CBC, so we've done Euclidean, but there will be revision next term. Okay, so don't stress. They will revisit it, but in the meantime, you can go and look at the recordings. I think they've done Euclidean geometry, but there will be revision. It just won't be like an intensive course. Mohammed, sine x plus x must be sine 2x. Okay. When are we doing financial maths? That will also be 3rd term, I'm sure.
Yes. But guys, I would like to point out to you that there is quite a lot of lessons that were taught last year that are sitting on either our website or on our YouTube channel. And you guys are more than welcome to go have a look. I think Ms. G, one of the other Watobe teachers, actually taught financial maths last year, and some of her stuff is really good. So you guys can go have a look at the Watobe YouTube channel. Also like and subscribe, you know, click the notification bell. I don't know what they say. That's what the YouTube content people say. Yeah, but please subscribe to our YouTube channel as well, and you'll find a lot of really good stuff there at the on our YouTube channel as well. I think I'm going to stop the recording, but for those of you who do want to go, you're more than welcome. Thank you so much for joining us, and we are going to see you guys again on Thursday. But if you guys have
You're welcome.